Hello everyone, this is Ashish and welcome again to YouTube. Welcome again to live channel of Infinity Learn JEE. So today I would be your host and I would be taking care of application of derivatives, right? So in this particular lecture we would be talking about the different problems, right, which has come in the previous years of JEE Main. Now through these problems we would be talking about the different concepts, right, different algorithm, different way in which we can think, interpret, comprehend the given question. So stay with me and we will dive into the world of application of derivatives. Now before we move further, right, सबसे पहले करना क्या है, हमें शेयर करना है, हमें लाइक करना है, हमें सब्सक्राइब करना है इस पर्टिकुलर चैनल को, ताकि जितने भी नोटिफिकेशंस हो, चाहे वो जेई मेंस के हों, एडवांस की वर्कशॉप्स हो, उन सब की इन्फॉर्मेशन हमें मिलती जाए. और अगर तुम लोग लाइक और सब्सक्राइब कर चुके हो तो फिर कुछ नहीं करना है यार, शेयर करो अपने दोस्तों के साथ. राइट, सो फर्स्ट ऑफ ऑल विल टॉक अबाउट द मास्टर क्लासेज. नाउ व्हाट आर मास्टर क्लासेज? मास्टर क्लासेज के अंदर हम लोग हर कंसेप्ट को राइट फ्रॉम द बेस टिल द एडवांस लेवल पूरा क्लियर करते हैं. These are not the chapters, right? These are concept. So हर एक वर्कशॉप, हर एक मास्टर क्लास एक सब कंसेप्ट पे होती है. फॉर एग्जाम्पल लेट्स से इफ आई टॉक अबाउट मल्टीनोमियल थ्योरम, सो मल्टीनोमियल थ्योरम पे एक क्लास होगा, एक क्लास ग्रुपिंग पे होगा, एक क्लास डिस्ट्रीब्यूशन पे होगा, एक क्लास इंडेफिनेट इंटीग्रेशन के केसेस के ऊपर होगा. सो हर एक कंसेप्ट के ऊपर देयर इज अ मास्टर क्लास. सिमिलर टू मैथ्स, physics, chemistry, biology भी मास्टर क्लासेस है. These master classes are there for you to understand the concept, the sub concept. अगर तुम्हें किसी प्रॉब्लम में, किसी कंसेप्ट में दिक्कत आ रहा है, join for these master classes. So what we have to do for these master classes? You have to visit our website, right? The link is in the description. Go over there and register for as many as master classes as you can, right? Because at the end, all of them are free. Yes, my dear friend, right? They all are free, so you can join for as many master classes. Now, apart from the master class, right, जो मैंने बताया कि वहाँ पे आपके concept को strong किया जाता है. So these are basically the concept building classes. Apart from it, you will also get the one Infinity Learn test series, mock test, or 12 previous year question papers, right, which would be good for you if you want to do a practice before your JEE mains, right, or before your JEE advance. So this is about the master classes. If you want to, go there, right, visit our website, or the link is also in the description. So open the description, click on the link and go to the website. You will find a plenty of master classes happening every day and you can join as many as you can, right? So now we'll move on to the application of derivative, where we would be talking about the different PYQs as I promised to you. So every question over here will talk about something different, some concept, some applications. So here is the very first example. The first example says the number of real roots of this equation, right? Now I have to find out the number of real root for this particular equation. Now how do we find out the number of root? For number of roots, there are two different methods available. If it's a polynomial equation, I can factorize it. If it's a trigonometric equation, I can factorize it. If it's an exponential equation, I can factorize it. So if I can factorize the equation, I can get the solution. The second approach is if I can draw the sketch or the graph of that particular function. Now if I draw the graph of the function, always remember through the graph I can only calculate the number of roots, not their exact value. Whenever the question says find the root, you always have to factorize it. That's the only way out. If it says number of roots, then obviously factorizing will also give me number of roots. Sketching will also give me number of roots. Sketching will not give me the exact value of the roots. The question says number of real roots, right? So I can also sketch this particular function. So in this particular example, what I'll do is I will sketch this particular function, we'll draw the graph and we'll see how many roots are there. Now, when I draw any particular graph, right, the graph cuts the x-axis. The number of point where the graph cuts on the x-axis will be equal to the number of roots. Or in short, I can say whatever is the root, the graph will cut the x-axis at that particular point. For example, the root is 2. So the graph will cut it 2, 0. Because if the graph cuts at the x-axis, it is that point on the graph for which y is 0. And for any equation, y needs to be 0. Hence, I know the number of roots will always be equal to number of intersection of the x-axis with the graph, right? So I want to talk about the number of real roots over here, right? What are you saying, sir? I want to join Sri Chaitanya. In which branch of Hyderabad will Ashish sir takes classes? Well, Ashish sir is right here available in front of you, right? So you can always have our classes over YouTube, right? But I am not available at Sri Chaitanya offline centers. I am only available for the online ones. Yet there are many good teachers at the offline centers, right? They are much better than me, much experienced than me. You can also join over there and you will have the same experience that you are having over here. Right, so we'll talk about the number of real roots of this equation. As we were discussing, I would be drawing the sketch of this particular graph because I can see number of real roots, so number of point of intersection. So I have the function y is equal to e raised to power 4x minus 2, sorry, plus 2, e raised to power 3x minus e raised to power 6 minus 6. Right, so if I have to find the graph, the first thing I have to do is differentiate this. So let us find dy by dx. Now what is dy by dx? dy by dx would be e raised to the power something, derivative would be e raised to the power something into derivative of something, that is 4, plus this would be 6 into e raised to power 3x, right? This would be minus e raised to power x, and the derivative of 6 would be 0. Now from here I can take e raised to power x common, so I am left with 4 into e raised to power 3x plus 6 into e raised to power 2x minus 1. So now this is my dy by dx. So now in this dy by dx, I can see two different terms. One is e raised to power x and second one is this particular bracket. E raised to power x, we all know it will always be positive no matter what x we take, right? For example, you put x is equal to 0, 1, 2, minus 1, minus 1 by 2, root 3, whatever you put, e raised to power x will always be positive. That's the nature of exponential functions, right? So this is always positive. So I don't have to worry about this. This is always positive. Now I have to think about this particular expression. I cannot comment right now whether this expression is always positive or negative. So if I have to find out, I have to take this as another function, right? So now we'll do the postmortem of this particular function and we'll try to find out what is the behavior of this particular expression. So I'm writing this as some other function fx, which is 4 into e raised to power 3x plus 6 into e raised to power 2x minus 1. So if I have to find out the behavior, I have to differentiate this function again. So I will differentiate this. What is f dash x? This is equal to 12 e raised to power 3x plus 12 e raised to power 2x, right? That would be the derivative. I can take 12 e raised to power x as common, e raised to power 2x I can take as common, so I am left with e raised to power x plus 1. Now if you observe, I have a very interesting terms over here. 12 positive, e raised to power x positive, in bracket I have e raised to power x plus 1. E raised to power x is positive. If I add 1, it will also be positive. So every term over there, no matter what x you take, this is always positive. So can I say f dash x is always positive? So if f dash x is always positive, which means the function is increasing, right? If the derivative is positive, we can always say function is increasing. So my fx is increasing. So fx is increasing function. So if fx is increasing, which means if I increase the value of x, the value of y will also increase. Now for this function, what is the domain? Domain is minus infinity to plus infinity. So let me find out the value at minus infinity. Fx. Right. Now observe carefully. If I put x to be minus infinity, e raised to power 3x. So this will be e raised to power minus into 3 infinity, which I can say this is equal to e raised to power minus infinity. I can also say this as 1 upon e raised to power infinity. So 1 upon infinity, which is 0, right? So I know this term is tending to 0. Similarly, this will also tend to 0 if x is minus infinity. So my answer is tending towards minus 1. And if I put limit x tending to infinity, that is the end point. So now observe, e raised to power infinity is infinity. So infinity plus infinity minus 1, right? So that would be infinity. So I know this would tends to infinity. So now if you observe the value of fx, right? When I start from minus infinity and go towards infinity, the value of fx will go from negative to positive, minus 1 to infinity. This is your fx. And this is your fx, right? This was your fx. So this fx is going from minus 1 to infinity. And this is multiplied with a positive value. So what can I say about dy by dx? So dy by dx would be negative, right? Now this fx will come from minus 1 to 0. So my dy by dx becomes 0, and when fx becomes positive, positive into positive becomes positive, and it will keep on increasing, right? So this is your dy by dx. Now look at your dy by dx, minus 1 to 0 to positive, which means that first my graph dy by dx is negative, so your y would be decreasing first, then it will take a turn, because dy by dx is equal to 0 means a turn, then my curve will show a increasing behavior. So my graph y will first start with a decreasing curve, will turn somewhere, and then it will always be increasing. So at x is equal to minus infinity, what is my value? Because the graph will start from minus infinity, right, the leftmost point. So if I put minus infinity, the powers are even, this is odd, so power is even, this becomes e raised to power 4 infinity, right, that is plus, this is minus, but this value would be way larger than this. So my answer would be going towards, right, sorry, yeah, so e raised to power 4x plus 2 into e raised to power 3x minus ex minus 6. So I am trying to find out the value at x is equal to minus infinity. So this is e raised to power 4x plus 2 into e raised to power 3x, right. It is 4x, right, not the x ki power 4. So if I put x tending to infinity, this would be e raised to power minus 4 into infinity. So this would be e raised to power minus infinity only, right. Previously I have mistakenly said that it is positive, right. So if I put x to be minus infinity, observe over here, e raised to power minus 4 into infinity. So this would be e raised to power minus infinity, hence going to 0. This will also be going to 0. This will also be going to 0. I am left with only minus 6. So I know my left end will start from minus 6. So now I will sketch a freehand graph. See, somewhere over here this would be minus 6, right. Now at x tending to minus infinity, my graph is over here. Then my graph will decrease. Hai na? This is a decreasing graph. I am just drawing a rough sketch. Then my graph will turn, and then it will be always increasing. Right? I am just drawing a free sketch, right? I am just trying to observe how many point of intersection this graph will have the x-axis. So I know this graph will look like this. So I will have only one point of intersection. If there is one point of intersection, so this equation will have only one real root, right? So this is how we can plot the graph and find out the number of roots. In plotting, you just have to do a rough sketch. That's it and nothing else. So number of roots, you can always draw the graph. Roots, if you have to find the value of the roots, factorization is the only approach. There is no other approach, right? Through graphical methods, we cannot find out the value. We can just find out the intersection, how many times it will intersect and so on. Right? So now we can move on to the next example, guys. Next example. Now it says r is the least value of a for such that the function x square plus ax plus 1 is increasing, and s is the greatest value for which the function is decreasing. Find the values of r and s. So in the previous example, we also discussed, right, when the function is increasing, the dy by dx needs to be positive. So if this function is increasing in 1, 2, so I know if I find out the derivative of fx, that will be equal to 2x plus a. Now 2x plus a needs to be larger than or 0 if the function is increasing. So now I need to find out the least value of a, right. Now this function is increasing for all the values of x between 1 and 2. Now if I talk about 1 and 2, let's 2x. If I put 2x, x is 1, I will get 2. If I put x is 2, I will get 4. So this value will always be varying between 2 and 4. And I have to make sure that 2x plus a needs to be always positive. So I can say that a minus 2 is the least value of a, right? Because if a is smaller than minus 2, for example, let's say a is minus 3. So if a is minus 3, then there would be some possibilities where 2x plus a will not be larger than 0. If a is minus 2, then no matter what x I take, 2x plus a will always be larger than or equal to 0. So this is the least value, right? The least value of a. Now this is r, right? R is the least value. So this is r. So now I am finding out the f dash x for the other function, that is also 2x plus a. Now it says it is decreasing. So it is less than or equal to 0. Once again, x is going from 1 to 2. So if this is going from 1 to 2, this would be 2 to 4. Now what shall be the greatest value of a, right, for which this expression is always negative, right? So this value is going from 2 to 4. So if a is -4, -5, -6, -7, any other values, 2x plus a will always be negative, right? Even I can also take -4.5, -5.62 and so on. Right, for all these values of a, observe 2x plus a will always be negative. So I can take all these particular values. I am finding out the greatest value. Now among the negative numbers, greatest value is the smallest value in the magnitude, right? So this is your greatest value, which is -4. So in this example, I can say s is -4. So r is -2, s is -4. What do I have to find out? I have to find out modulus of r minus s. So modulus of r minus s would be equal to modulus of r, that is -2 minus of s. Right? So I will get answer as 2. So now we can move on to the next example. Now let us see the next example. देखो क्या बोल क्या रहा है? Next example में fx is एक function given है sin में, right? And we have to find the increasing or the decreasing behavior. It's a very simple question, right? There is an equation given in the sign, right? And I have to find the increasing or decreasing. So I will use the same concept. For increasing, dy by dx is positive. For decreasing, dy by dx is negative. So we'll differentiate this particular equation. So we'll differentiate first and then we'll see what we have to do. So we'll differentiate. This becomes 12 sin cube x and derivative of sin is cos x plus 30 sin square x into cos x plus 12 sin x into cos x. Derivative of -3 is 0. तो अपने पास f dash x आ गया. अब यहाँ से पहले f dash x को will simplify. So I can take something common, right? We can take 6 sin x cos x, 6 sin x cos x common. So if I take 6 sin x cos x, I am left with 2 sin square x, right? That is from here, from this term, I can write 5 sin x, and from this 2 will be left. So 6 sin x cos x, I can take 3 out and 2 sin x cos x, right? 2 sin x cos x is nothing but sin 2a. So I can write this as sin 2x. This is, I will factorize, right? Because if you observe, this looks like a quadratic in sin x. So for quadratic, we can do the middle term splitting. So 2 and 2 is 4, this is 5. So 5 I can write as plus 4 sin x plus x plus 2. So now I get 3 sin 2x. I can take 2 sin x. Yes, sin x plus 2 is one factor. What is the other factor? 2 sin x plus 1. Right? So I have factorized this. I have taken 2 sin x common from here. So I will be left with sin x plus 2. 1 from here. So sin x plus 2 into 2 sin x plus 1. Now this is your dy by dx. अभी क्या करेंगे इसके साथ में? हमें इंक्रीजिंग डिक्रीजिंग बिहेवियर देखना है. सो फॉर इंक्रीजिंग डिक्रीजिंग बिहेवियर f dash x needs to be larger than 0, less than 0, right? So first I am trying to find out for increasing. For increasing, this needs to be larger than 0, right? So now my x is going from where? X is varying from pi by 2 and this is minus pi by 6, both equal. Now observe over here, sin x plus 2. Now no matter what x I take, sin x will always lie between -1 to 1. So sin x plus 2 will always be positive. So I don't have to worry about this bracket. No matter what x I take, sin x plus 2 is always positive, right? So now we can go over here, 2 sin x plus 1 and sin 2x, right? Please bring physics faculty Janardhan sir as he teaches up to Olympiad level. Yes, sure. We would like to bring him, right? Thank you so much for your suggestion and feedback. So where was I? हाँ क्या कर रहे थे अपन लोग, या f dash x positive, right? So this is positive, so we don't have to worry about it. Now sin 2x may or may not be always positive. 2 sin x plus 1 is may or may not always positive. So we'll try to find out for x. So x goes from minus pi by 6 to pi by 2. This is the range in which I have to figure out, right? Now this is 2 sin x plus 1. So 2 sin x plus 1. Now see, from here you can also write it down as sin x is equal to minus half, right? So if I take sin x to be positive, 2 sin x plus 1 is always positive, right? So I know if there is a 0 over here, this is always positive. From 0 to pi by 2, 2 sin x plus 1 is always positive. Now I have to check between 0 and minus 30, that is in the fourth quadrant. So sin x would be negative over here, and sin x will be equal to minus half. So sin x will be equal to minus half at what angle? In the fourth quadrant. So sin x will be half at 30 degrees. So I know this is minus 30 degrees, right? And this is also minus 30 degrees. So I know at this particular value, 2 sin x plus 1 would be 0. Now let us talk about in between this angle, right? In between this angle, this will always be positive. So I know this expression is also positive between minus pi by 6 to pi by 2. Why am I saying between 0 to minus pi by 6 this expression is positive? Because if you see minus pi by 6, I am getting a 0. If I move from minus pi by 6 to 0, right, or I am moving from the fourth quadrant, this angle to this angle, right, I am going from here. Now over here sin x becomes 0. So if sin x becomes 0, I am moving towards 1. So from 0 to 1 I have traveled, right? So the values would be positive values, and this is positive. So this we got for this bracket. So this is also positive. Now this sin 2x. Now if I talk about sin 2x, multiply this by 2x. So you will get pi by 3 pi, right? So this is 2x. So between minus pi by 3 to pi, this is 2x. So sine would be going from minus pi by 3 to pi. So I can say when 2x is going from minus pi by 3 to 0, then this is negative. And when it goes from 2x pi, this is positive, right? 2x. So sine of 2x. Sine is positive in the first and the second quadrant, negative in the third and the fourth quadrant. This is your fourth quadrant, this is your first and second quadrant. Now divide by x once again. So minus pi by 6 to 0, this is negative, and if we divide by 2, this is positive. So this term is negative over here and positive over here, right? So if I talk about 0 to pi by 2, positive, 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 the answer is positive. So our function is increasing. So over here I can say my function is increasing, and over here my function is decreasing. Why it is decreasing over here? This is positive, positive, this is negative. If you multiply 2 positive and 1 negative, your answer would be negative. So now if I see the options, right, 0 to pi by 2 states decreasing, by while we have increasing, decreasing we have minus pi by 6 to 0. The answer is option number D. Right guys, so this is how you can solve, right? The question was pretty simple. You have to find the increasing and decreasing. I have to differentiate this. You got the dy by dx. Now the next story comes once you solve dy by dx, because then after it was a pure trigonometry which I have used over here to find out the signs of every bracket. So it is not mandatory that every time when you do f dash x you would be able to find out whether f dash x is positive or negative. Sometimes we have to hustle a bit, right? थोड़ा सा लॉजिक लगाना पड़ता है वहाँ पे. That's why I always say, right, mathematics, physics, or whatsoever we study as far as JEE is concerned, you need to study the common sense first, right? Apply your logic, stay with your logic, right? Then after we can learn everything, whether it's maths, physics, or chemistry, or any other subject, right? No matter what subject you wish to study, not in 11th and 12th. Let's say if we talk about engineering or post-engineering. If you have your common sense, now 50% of these syllabus or 50% of the question you can easily comprehend. For the remaining 50%, you need your acumen or the knowledge. So now we have the next example. The example says we have a function. Function is increasing in the behavior, so we have to differentiate this and find the dy by dx. Dy by dx positive means function is increasing. Right, so without wasting any more time, I will just differentiate this function directly. So what is my f dash x? So I have a piecewise function, so I will have two derivatives over here. So for x larger than 0, my derivative would be minus 4x square plus 4x plus 3 for x larger than 0. And for the denominator, sorry, for the second part, this is product rule. So I will use the u into v rule, x into e raised to power x plus 3 into e raised to power x, and x is less than or equal to 0. Right guys, so this is the derivative of f dash x. Now fx is increasing in which of the interval? So I have two different possibilities. I have to check whether fx is increasing over here. Then if it is increasing, in what interval it is increasing, then I have to check for this as well, whether the function is increasing or not. So now I will start with the first part. That is my derivative, right? So minus 4x square plus 4x plus 3. Right, so take minus out, you will have 4x square minus 4x minus 3. It is a quadratic, right? So for this quadratic, we will find out the roots. Can I find out the roots by middle term splitting? 12 minus 12, so minus 6 and 2, right? So we can always look for middle term splitting, right? If in the first 5 seconds you don't find anything that splits, right, then use the formula directly of the quadratic equation. So now you have 2x minus 3 plus 2x minus 3. So we got 2x minus 3, okay, this is minus, and I got 2x plus 1. So now I will plot the number line. I have minus 1 by 2, 3 by 2. I have a minus sign, so all the sign would be reversed. This is minus, this is plus, this is minus. So I know this function is increasing when I have a positive sign. So dy by dx needs to be positive. So it is minus 1 by 2 to 3 by 2. Do I have minus 1 by 2 to 3 by 2? No, I don't have, right? Minus 1 by 2, 3 by 2. So we'll keep this as it is and we'll find the increasing behavior in the second part. For x negative, acha, this is for x positive, whereas I am getting this answer. So if I simplify, my answer would be right from 0 to 3 by 2. Hai, because this particular case is only valid for x larger than 0, whereas if you observe, I am getting answer between minus 1 by 2 to 3 by 2. So if x is positive, this becomes my final answer for this particular case. Now I am solving the second case. For second case, remember x will always be less than or equal to 0. So if I take 3 into a raised to power x common, I would be left with x plus 1. Now this is my dy by dx, right? So e raised to power x, once again, no matter what x you take, this is always positive, right? So I always love, right? I always love whenever e raised to power x or any exponent come in the equation, because they are very cute numbers, right? Because they are always positive. They don't bother us a lot. Polynomials, trigonometry, right? Especially trigonometry, that bothers us a lot. Sometimes they are positive, some angle they are negative, right? This is one of the cutest, right, function that I always prefer. Right, so 3 into a raised to power x, always positive. So I don't have to worry about this cute thing. X plus 1. So x plus 1, I know at minus 1 it would be 0, right? If I take x to be larger than minus 1, this would be positive. If I take x to be less than minus 1, this would be negative. So I'll plot minus 1. I know over here this is positive, over here this is negative. But as we can say, this expression is only for x less than 0. Right, so we are looking for increasing behavior. Where do I see the positive sign? So I see the positive sign between minus 1 to 0. So this function fx, the derivative is positive in this interval and in this interval. So I can combine both of them and I can say from minus 1 to 0, 0 to 3 by 2. So in short, minus 1 to 3 by 2, my function is behaving a increasing nature. So minus 1 to 3 by 2. I have this option over here. Option number C is your correct answer, which is minus 1 to 3 by 2. Right? So now we'll move on to the next example. Rolex theorem, right? So what is Rolle's theorem? Rolle's theorem says if there is any function, right, fx, which is continuous and differentiable, fa is equal to fb in a comma b. So if there is a function which is continuous in a comma b, differentiable in open bracket a comma b, and fa is equal to fb, then there exists at least one C such that f dash C is equal to 0 and C belongs to A comma B, right? This is what the Rolex theorem says. Now over here it says Rolex theorem holds true for this particular function, which is fx is equal to x cube minus ax square plus bx plus 4 and between 1 comma 2. So A is 1 and B is 2. This A and B, right? These A and B are different. So and f dash 4 by 3 is equal to 0. So what can I say? This function, the polynomial given over here, needs to be continuous and differentiable. Polynomials are always continuous and differentiable, right? They are once again one of those cute expression. So fa needs to be equal to fb. What is a and b? 1 and 2, right? So I know f1 should be equal to f2 if Rolle's theorem is applicable. So over here I can say f1 is equal to f2. So we'll try to find out the value of f1. Put x is equal to 1, guys. So 1 minus a plus b plus 4. This is equal to 8 minus 4a plus 2b plus 4. So 4 gets out with 4. Take 4a over here. So this becomes 3a minus b is equal to 7. So I got the first equation in a and b. If I get one more equation, my job is done. I can find out the values of a and b, and that is what being asked, right, in the question as well. One more condition is given, f dash 4 by 3 is equal to 0, which means f dash c is 4 by 3. Or let's say if I don't know c, I know the derivative at 4 by 3 will be equal to 0. So I will find the derivative of my function. Where is my function? This is my function. So I am finding out the derivative of f dash x. It would be 3x square minus 2ax plus b, right? The derivative of this function, the polynomial. This will be the derivative, 3x square minus 2x plus b. Now I know f dash of 4 by 3 will be equal to 0. So replace x by 4 by 3. So 3 into 16 by 9 minus 2a into 4 by 3 plus b. This will be equal to 0. If I multiply, this is 3. Multiply by 3. So 16 minus 8a plus 3b is equal to 0. So I can say 8a minus 3b is equal to 16. So now I have two equations and two variables. We can solve them to find out the answer. You can use any approach. So I am finding out b from here and I am replacing b in that particular equation. So this equation becomes 8a minus 3. What is b over here? B take on this side, 7 goes on this side. 3a minus 7 is equal to b. So 3a minus 7 is equal to 16. Quickly we'll simplify this. 8a minus 9a is minus a plus 21 is equal to 16. So from here I can say a is nothing but equal to 5, right? If a is 5, if a is 5, this would be, this equation would be balanced. So if a is 5, put a in this equation or that equation, you will get the same answer, right? So we all know these tricks. Put a over here, this becomes 15 minus b is equal to 7. So we can say b is nothing but b is equal to 8. So where do I see a 5 and b 8? Option number A, right? A for Ashish is the correct answer. So now we can move on to the next example. What does the next example says? The sum of all the local minimum values of this twice differentiable function f, which goes from r to r, defined by this. Abhi dekho, this function looks so scary, right? Sum f double dash 2, f double dash 1 and something, right? Always remember, most of the time inside the competition exam, they try to scare you. But remember, the concept, the fundas, the approaches remains exactly the same. If you observe so far, whatever approaches I have used, right, you already know about these approaches. Then why there is a difference that a teacher is being able to solve all and we are not able to solve inside the examination hall? Because of that scared, right? Because of the fear that, oh my God, this is a scary expression, right? So trust me, everything is cute in this world if you look them as. Now observe over here, this is what? F dash of f double dash of 1, right? So whatever it is, f double dash of 1, I know at the end f double dash would be some expression, and if you put 1 in this, that will be a constant, right? It is just a number, right? Instead of saying 2, 3, घुमा फिरा के मुझे बोल रहा है कुछ तो, right? So now we don't have to worry about them. I know they all are constant. Remember this concept, right? Because these kind of questions you will always find in calculus. Instead of writing 2, 3, they will write f dash 3, f double dash of 1 minus lambda. At the end it is constant, right, and nothing else. So now I have a fx. Fx is given by what? X cube. So it's a cubic equation, that's it. Right? Now the answer or the approach is also hidden in the question itself. I have given fx and I can see f double dash 1, f double dash 2. Right? So we have to double differentiate the function, and after double differentiating it, we'll put x is equal to 1 and x is equal to 2. So now quickly double differentiate this. So f dash x, x cube becomes 3x square. This becomes 6x. Now this is a constant, right? So constant into x, derivative would be the constant itself. So minus 3 f double dash 2 by 2. And this bichara is a constant, so derivative would be 0, right? So now I have the f dash x. Now I will double differentiate this. So I am differentiating to find out f double dash x. This would be 6x minus 6. This is a constant. Derivative is 0. So now I got f double dash. Put f double dash of 1. Right? I need to find out 1 and 2. Nah? So put x is equal to 1. If I put x is equal to 1, this becomes 0. Put x is equal to 2. If I put 2, 12 minus 6 is 6. See, I got f double dash 1 and f double dash 2. So all those things which were scary in this particular example, I have figured out their values. So now I can write my cute fx, which is given by x cube minus 3x square. F double dash 2 is 6. So if I write 6, 6 by 2 is 3. 3 3s are 9. So I have minus 9x. What is f double dash of 1? 0. So this is my fx. What do I have to find out? The sum of all local minima value. Okay, fine. So we have got fx only, right? We have to find the local minimas for them. So now it's a polynomial, right? Now it's an easy peasy game for us. We'll differentiate this. 3x square minus 6x minus 9. So now I will equate this to 0 to find out the critical points. So if I equate this to 0, this becomes 3 into x square minus 2x minus 3 is equal to 0. So from here I'll get 3 into x minus 3 into x plus 1 is equal to 0. So I got x is equal to 3 or minus 1. Right. But x equal to 3 or minus 1, do I have a local minima or I have a local maxima? Right. So how do we find? I'll give you a trick. We won't find d2y by dx square. Whenever you have a local minima, this is how the graph would be. And when you have a local maxima, this is how the graph would be. dy by dx is 0 over here, dy by dx is negative over here, dy by dx is positive, right? The slope of the tangent. Slope of the tangent. These are the sine of dy by dx. So now I will plot number line. This is my dy by dx. Plot the values minus 1 and 3, wavy curve method. Now see, at minus 1, I am going from positive to negative. I am going from positive to negative. So I know this is nothing but local max. At 3, I am going from negative to positive, negative 0 positive, negative 0 positive. This is my local min. So I am getting local minima at only one point, that is x is equal to 3. The question says find the sum. So sum is basically the value of f3, right? Find the value of f3 and that will be your answer, right? So we can do that calculation, right? So now I'll move on to the next example and I am tired. Right, so you guys can try, right? In the meantime, I will have a glass of water. So try this particular question. It says the shortest distance between the line and the curve. How would you find the shortest distance between two lines? Yeah guys, so I am back. So where were we? We were finding out the shortest distance between the line and the curve, right? The shortest distance, let's say if I have to walk, right, to you by a shortest distance, I will walk perpendicularly, right, or on the perpendicular. So we all know shortest path is always along the normal. So let's say whatever this curve is, I don't know what that curve is, right? X square is equal to 2y. And there is this line. So x minus y is equal to 1. So the shortest distance would be along the normal, right? So if along the normal, then I should have a tangent over here. tangent is also perpendicular to normal. So this line and this line is parallel. So the slope of this line m is equal to 1. So I can say slope of my tangent is also m is equal to 1. Let's say this point is x1 comma y1. So now I can say at this point P, x1 comma y1, the slope of the tangent is 1. And what is the slope of the tangent? Nothing but the dy by dx. So I will differentiate this and find out the dy by dx. So 2 dy by dx, this is equal to 2x. So I know dy by dx is nothing but equal to x. And dy by dx has to be equal to slope. So this is equal to 1, right? y1 because the slope is 1, right? So at x1, y1, the slope is given by x1, which will be equal to 1. So I got the value of x1. If I know the value of x1, how do I get the y? I know this point also lies on the curve. So if I put x is equal to 1, y becomes 1 by 2. So I got the point, right? Now I have to find the shortest distance. This is my distance d. Now this is basically a point and a line. I have to find the perpendicular distance. So it's a 2D formula. D is equal to, line is x minus y minus 1 is equal to 0. Point is 1 comma half. So if I have to find the distance of this point from this line, how do we do it? We put the point in the equation of the line. So 1 minus half minus 1 upon under root of coefficient of x whole square plus coefficient of y whole square. 1 minus 1, this would be 1 by 2 root 2, right? That is your answer. So 1 by 2 root 2 means option number B is the correct answer. So now we move on to the next example. Now next example says two curves are at right angles, right? So when two curves are perpendicular, normally we talk about two lines, right? Two lines have an angle of intersection. When we talk about the two curves means the angle between their tangents at their point of intersection is basically known as the angle between two curves. So if these are two curves, let's say these are two random curves. So if I have to find the angle between them, so angle between them is at the point of intersection, you draw the tangent to this curve, you draw the tangent to this curve. This angle is known as the angle between two curves. So don't get confused when somebody says find the angle between two curves. It is just the angle between their tangents drawn at the point of intersection. So now I have two curves given and they are at right angles. So I can say the slope of their tangents m1, m2, the product will be equal to minus 1. That is what we have learned, right? So m1, m2, this would be equal to minus 1. Straight line में पढ़ा है अपन नहीं है ना? So अभी मैं करूँगा, let's say point P is some x1 comma y1. So I will differentiate and find the slope. So the derivative of the first curve, x is equal to 4 y cube dy by dx. So dy by dx will be equal to 1 upon 4 y cube. That is my slope 1. What is the next curve? xy is equal to k. So if I differentiate, that becomes x dy by dx plus y is equal to k is 0, right? So from here I get dy by dx is minus y1 upon x1, right? So I'm writing y1 over here. Now product of these two would be equal to minus 1. So I can say 1 upon 4 y1 cube into minus y1 upon x1. This is equal to minus 1. So I got 1 upon 4 y1 square into x1 is equal to 1. 4 y1 square into x1 is equal to 1. Now x1, y1 will also lie on the curve, right? So I can say x1 is equal to y1 raised to power 4 and x1, y1 is also equal to k, right? Because the point will also lie on both the curves. So now from here, what do I have to do? I have to find out the value of k. Okay. ठीक है. So यहाँ से पहले अपन y1 की वैल्यू निकालते हैं. So in this expression, replace x1. So you get y1 square, y1 raised to power 4. This is equal to 1. So I get y1 raised to power 6 is 1 by 4. So I got y1 is equal to 1 by 4 raised to power 1 by 6. So I got y1. I can also find out the x1. What is x1? y1 raised to power 4. So this power 4. So now I have x1, y1. What is k? K is x1, y1. So k is x1, into y1. So k will be equal to 1 by 4, 5 by 6. I have to find out 4k. So multiply this by 4. So 4k is 1 by 4, 5 by 6 into 4, right? Then I have to take the power 6. So 4k raised to power 6. This becomes 1 by 4 raised to power 5 into 4 raised to power 6. If I simplify, I get 4. So my final answer for this particular example would be 4. So always remember, angle between two curves is nothing but the angle between their tangents. And how do I find the slope of the tangent? I differentiate them, right? So if you differentiate any particular curve, you always get the slope of the tangent at a given point x. Right, so the last question of this particular session, we would be talking about the local maximum value of this function. Now look at the function 2 by x raised to the power x square. Now one more concept, one more funda. Whenever you see a variable raised to power variable, means base में भी variable है, power में ही variable है. ये देखो, ये मेरा base है ना 2 by x, है ना, और ये power में x square है. So whenever you see a base raised to power, or sorry, whenever you see a variable raised to power variable, we will always take a log. So remember this tip. What is the tip? Whenever it, कहीं पे भी हो, right? जरूरी नहीं है AOD. Whenever, in every example of mathematics, wherever you see variable raised to power variable, you have only one tool. Take log. That's it. This approach can only save you in that particular example. No other approach would be possible. So now over here I have fx. Fx is given as 2 by x raised to the power x square. So I'll take log. So log of fx is equal to log of 2 by x raised to the power x square. So x square will come out. It becomes x square into log 2 by x. So I can write this as x square log 2 minus x square log x. So this is my log of fx. Now I will see what I have to find out in this particular example. So it says local maximum value. Okay, very good. So local maximum value means I have to differentiate this and find dy by dx. So now you differentiate this. So log of fx is 1 upon fx into f dash x. What is the derivative of this? 2 log 2 into x minus derivative of this would be product rule. So x square into 1 by x minus 2x log x. So I get this is 2 log x. How come I got 2 log x? Sorry, I have written it wrong. It was x square log 2, right? So 2x log 2, right? That was the derivative, and rest everything is good, right? Cool. So this becomes x. So now I have 2x log 2 minus x minus 2x log x, right? This is the function 2x log 2 minus 2x log x minus x, yes. So now this is my derivative of this function. Now this derivative needs to be 0. So if this is equal to 0, from here I have to find out the value of x. So can we find out the value of x from here? It is x into this is 2 log 2. So log 4 minus 1 minus 2x log x, right? So I can take x common. It becomes log 4 minus 1 minus 2 log x is equal to 0. So either x is equal to 0, but x cannot be 0 because the question says x is larger than 0. So x is not 0. So this expression needs to be 0. So now I'll solve it over here. Log 4 minus 1, log 4 minus 1, this is equal to 2 log x. So from here we'll get the value of x. X will be, this I can write as log 10, right? The base is how much? The base is e, right? Okay, so this is log 4 by e, right? So I can write 1 as log e upon 2. This is log x. Log x is log 4 minus e upon 2, yeah. So x would be equal to e raised to the power log of 4 by E by 2. So now I got this point as x where my derivative is 0. So I have to find out the local maximum value. So put this value of x in the function, you will get the local maximum value. So if I put, my answer would be what? 2 by x. So what is x? So it becomes 2 into e raised to the power minus log of 4 by e by 2. This is 2 by x whole raised to the power x square. So what is x square? E raised to the power log of 4 by e. Right? That is your x square, because if I take the square of this, 2 will cancel out. Now, how to simplify this? I would be using a property over here, and the property says, I'm running out of space now. The property says a raised to the power log of b to the base a, right? If there is an indice, the base is a, and in the power there is a log, and the base of the log is also a. So a raised to the power log b to the base a, this is nothing but equal to b. Right. Same thing I can apply over here. See, e raised to the power log 4 by e. The base is also e for this log, right? So this is e. So this becomes equal to 4 by e only. This becomes equal to 4 by e only, right? This. And for this, I'll give you a trick. See, this is minus 1 by 2. Take minus 1 by 2 inside. So if minus 1 by 2 goes, it becomes 4 by e raised to the power minus 1 by 2. Whole raised to power, this was 4 by e. I have replaced this by 4 by e. Now see, e raised to power log of something to the base e. So this becomes 2 into 4 by e raised to the power minus 1 by 2 into 4 by e. Right. So this becomes your answer. So whenever you see variable raised to power variable, always remember you have to take the log on both sides and then differentiate. So once you differentiated it, right, we did dy by dx is equal to 0. From there we got the value of x. Now x is this property. Either you can use it over here or you can use it at the end when you have simplified your answer. Now you can simplify this value and you'll get your answer over there, right? So that is all, right, with the example that I bought for this particular session of AOD. Now before we move towards the end, there is something that I wish to talk about, which is known as Triple R batch. Triple R was the rapid revision batch. In this Triple R batch, this is only for JEE 2022 aspirants who are preparing for mains and advance. Now in this particular batch, we give you the live classes through the top educators, teachers, right, who will be teaching you all the concepts, all the topics which are required for JEE mains or advance. So all the lectures for PCM will happen, right? This is YouTube live. So not on this, we have a different portal. So on that portal, these lectures would be happening, right? Apart from the lectures, right, you also get the self-learn videos, which are the pre-recorded videos. If you want to learn something else as well, you can learn through it. You also have the flashcards. Flashcards are where, you know, you can learn to memorize your formulas, concepts, theories and stuff, right? So flashcards are indeed an interesting thing, you know, when preparation comes into picture. Then you have plenty of tests, which are the daily tests or the test series or the adaptive tests, right, for the Triple R students. As I mentioned, this is only for, right, JEE 2022. The first thing that I talked about in this particular workshop, where we talked about the master classes. Master classes is open for everybody. Triple R is only for 2022. So with this, we come to an end of this particular session on AOD. Thank you so much for being here. Thank you so much for listening to me. I will be meeting you once again in the coming days with some more lectures on JEE. Till then, enjoy your day and keep learning with Infinity Learn.